All right, so today I am covering systems of equations. So what is a system? So a system is a set of two or more equations that we consider together. And we indicate that we have a system by basically lining the equations up vertically and then putting the curly brace in front of them to just indicate that these are combined, these are taken together. It's different than if you just wrote the two equations like on a piece of paper. It's not clear that those are part of a system, so that curly brace is specific to say these are taken together. When you have a system and you're finding a solution, you're finding an ordered pair that works in both equations of the system, or if you have like three or more equations, in all of the equations in the system. So your solution is not just a set of x and y that works in one equation, but it also needs to work in the second equation. So when you're solving a system, you're looking for a single ordered pair that works in all the equations. And since we're dealing with x and y, we can graph these. And when you graph them, your solution is the intersection. So where all of the graphs cross, that point is your solution, because that ordered pair is on every single one of the lines. Or you could have systems that are not lines. You can have parabolas in your system. You could have other types of equations. So it's just where they intersect. So the most common way that we solve systems is by using substitution. And all the problems that I'm going to be doing are involving lines because those are the easiest to solve. So we're going to be solving linear systems, meaning that they're all linear equations in there. So the basic steps are, first you solve one of the equations for a variable. You either solve for x or y. And if they're already solved for a variable, that's awesome. That's one less step to do. And then you substitute that into the other equation. So you're plugging one equation into the second. And then that gives you an equation, a new equation with only one variable in it, so you can solve for that variable. So that will give you an answer to either x or y. And then you take that answer and you plug it back into the first step so that you can find the other variable, because there's going to be two answers, an x and a y. And so you evaluate it, that gets you your y value or your x, whichever one you did second, and your answer is an ordered pair. So you're not just solving to find an x, you're solving to find a y, you're getting an ordered pair. So I've got several examples here. The first one is to solve by substitution. So I have two equations here. They're both linear. You can see that they're in slope-intercept form. And the first step would be solve for a variable. These are both solved for y, so we don't need to do that because that step's already done. The second step is to substitute one equation into the second. So if we look at this, if they're both equal to y, then I can take the second equation and replace y with what y is equal to in the first equation, the 10x minus 2, because they're both equal to y, so y has to be the same thing. The y in one equation is the same y as in the second equation. So basically, I'm taking the second equation and plugging it into the first. So this gives me 10x minus 2 is equal to negative 2x plus 6. You can think of it as you're setting the equations equal to each other because they're both equal to y, and y equals y. So now I have an equation where I only have x, and so then I can solve for x. So I'm going to start by adding 2x to both sides. So I like to put my x on the left. That gives me 12x minus 2 equals 6. Then I'm going to add 2 to both sides, since I want to isolate the 12x. So that gives me 12x equals 8. And then I need to divide both sides by 12. And that gives me x equals 8 over 12. But we can also reduce that. I can divide them both by 4. 8 divided by 4 is 2. 12 divided by 4 is 3. So x is equal to 2/3. Now we're not done. Normally when you're solving for x, you're like, okay, I'm all done. But you're not done, because when you have a system, you also need to figure out the y, because their solution's an ordered pair. So I need to take 2/3 and plug it back into one of my equations. It doesn't really matter which one we use. I'm going to just plug it back into the first one. So we have y equals 10x. Now x is 2/3, and then minus 2. So now I need to evaluate on the right side. I need to figure out what is y equal to. So 10 times 2/3 is 10 times 2 gives me 20, and then over 3. And then we need to get a common denominator here. We need a denominator of 3. So I'm going to rewrite the 2 as 6/3 because 6 divided by 3 is equal to 2. So those are equivalent. And then I can do that subtraction. 20 minus 6 is 14/3. So now I have x and I have y, and I can write my ordered pair, x comma y. So our answer is 2/3 comma 14/3. And you can always check your answer by plugging your x value into the second equation to see if you get the same thing. So we can check it by plugging 2/3 into our second equation. So if we have y equals -2 times x, which is 2/3, plus 6. So that would give us -4/3. And now I need to convert this to 18/3 because 18 divided by 3 is 6. And then you can see -4 plus 18, that gives us 14/3. So we got the same value for y. And so that same x value gives us the same value for y. So that means this ordered pair is a solution to both of these equations. So it is the solution to the system. Here we have a second example. We have y equals -3x minus 1 and 2x minus 3y equals -8. So the first equation is already solved for a variable, so I can plug that directly into the second equation. So my second equation, I have 2x minus 3y. Now we're multiplying here, and y is more than one number, so we need to have parentheses here. And I'm replacing y with y equals, and then that's -3x minus 1. So y is equal to multiple things, so it has to be in parentheses. And then this equals -8. So I took the -3x minus 1 and substituted that in for y because y is equal to -3x minus 1. So now I need to solve this equation, so we need to distribute, add like terms, go through our whole solving process. So I have 2x, and then -3 times -3 is a positive 9, so I get plus 9x. Then -3 times -1 is a positive 3, and then this equals -8. 2x plus 9x is 11x, so we get 11x plus 3 equals -8. I will subtract 3 from both sides. This gives me 11x equals -11. I divide both sides by 11. And we get x equals -1. So now that I know x, I need to determine what y is. So I'm going to take the first equation that we have solved for y. So y is equal to -3x minus 1. So that's -3 times -1 minus 1 because x is -1. So -3 times -1 is 3. So we have 3 minus 1, and it gives us a y value of 2. So our ordered pair is -1, 2. And that is our solution. So how do we interpret these solutions, and specifically for linear systems where we have lines? So we've just seen two examples where we got one solution. And if you were to graph these lines, that's the intersection point. They intersect at one single point. Now, in order for two lines to intersect, their slopes cannot be the same. So the slopes are not equal. And then we have a specific term for if you have one solution. We call it a consistent system with independent equations. So the equations are independent, meaning they're not the same, and it's consistent because there's a solution. So there are other possibilities because we could have equations where there's infinite many solutions or no solutions. We haven't seen any of those yet. If you end up with infinite many solutions, that means you have two identical lines because they overlap everywhere and they overlap at infinite points. So if the lines are identical, that means their slopes have to be the same and their y-intercepts are the same. Now this system is still a consistent system because we have a solution, but they're dependent equations because they're the same equation. Now the last possibility is having no solution at all, and this is when they don't intersect. So the only way for two lines to not intersect is if they're parallel. So if you have parallel lines, you have no solution. And just like with infinite many solutions, they have the same slope, but their y-intercepts are different. So you can take your equations and put them in slope-intercept form, and then looking at the slope and the y-intercept, that can tell you whether you have a solution, if you have multiple solutions or no solution. Now, if you have no solution, we call it an inconsistent system because there's no solution. But the equations are still different, so they're independent. So we've got different types of systems, but you can determine how many solutions you have just by looking at it in slope-intercept form. Or you can graph the lines, and then you can see. So here's another one. We're going to solve this by substitution. Now in this case, we don't have an equation that's solved for y or solved for x, so we have to solve one of these equations. So there are two ways we can do this. We can take the first equation and solve that for y by adding 2x to both sides. Or we can take the second equation and solve for y by dividing everything by 2. Either way, as long as you do your algebra correctly, you'll get the same answer. Now, I am personally inclined to take the first equation and solve for y. So we have y equals 5 plus 2x when we solve that because we're adding the 2x to both sides. So now I'm going to plug that into the first equation, or the second equation. So the second equation is 2 times y, and y is 5 plus 2x. So it's going to be 2 times 5 plus 2x. This equals 4x plus 10. So now I'm going to distribute. 2 times 5 is 10. 2 times 2x gives us 4x. And we have 10 plus 4x equals 4x plus 10. Now you may notice our left side is equal to the right side. So when I subtract my 4x so I can put it on the left, the 4x minus 4x cancels, and we're left with 10 equals 10. So 10 equals 10 is a true statement. We don't have any variable anymore. The variable means that it doesn't matter what x is. So we learned about this when we were solving linear equations, that there are times where your x cancels out and you either have no solution or infinite solutions. Here we have infinite solutions because 10 equals 10 is a true statement. So we have a true statement which tells us we have infinite solutions. So our solution is all real numbers. Oh, it would help if I spelled infinite right. So we could write it as interval notation, negative infinity to positive infinity, because our solution, it's the solution set as basically any possible number. You could write all real numbers. And another option for writing is to write it as a set, where you kind of say, okay, it's some ordered pair x comma y, where, and then you take your equation that you solved, y equals 5 plus 2x. And we're basically saying any number that works in that equation is a solution. So there are 3 different ways to write your answer when you're indicating that there are infinite solutions. You can use interval notation, you can say just all real numbers, or you can write it as a set where you take your equation that's solved for a variable and you put it into the set notation. Okay, now here's another example. We have negative 2x plus y equals 5 and negative 2x plus y equals 10. So if you notice the negative 2x plus y, negative 2x plus y, those are identical. So I could do a substitution here immediately, but that's usually hard. People don't normally see that. So I would, again, solve one of these equations for y. So if I solve the first equation for y, I'm adding 2x to both sides. You see this is the same equation that we had in the previous example. And so let's plug that into the second equation where we have negative 2x plus y, and y is 5 plus 2x, and that equals 10. So if you want, you can put a little 1 there just to kind of show that it's 1y. So 2x plus 5 plus 2x equals 10. And the negative 2x plus 2x, those cancel, so you're left with 5 equals 10. And of course, that is false. That is not true. And so that tells us there is no solution. And so we can use our shortcut for no solution, which is the empty set symbol. That's usually what I do. Or you can literally write it as an empty set where you just have the curly braces with nothing inside. Or you can say no solution and use the words. So that when you're solving and you get a contradiction, you get something that's false, that's no solution. Our previous example, we got something that was true, so that's infinite solutions. Now there's a second method that we can solve systems, and that's called elimination or addition. Both terms are used interchangeably. It depends on the textbook, what title or name is used. I call it elimination because your goal is to eliminate a variable. Addition is used because you're adding equations together. But you want to be aware that these are basically the same thing, just different names. So the steps are, it's a little more steps, but I actually find it more organized. You write both equations so that the variables are on the same side. So you want to make sure that x and y are on the same side. Then if you have any fractions or decimals, you clear those by multiplying by like a power 10 to get rid of any decimals, or multiplying by the common denominator. And then you need to pick, what variable do I want to get rid of? Do I want to get rid of x or do I want to get rid of y? And you want to pick the one that's easiest. So once you've decided which variable you want to get rid of, you multiply, oh, that should say or, not of, one or both equations by a number so that the coefficients for the variable you want to get rid of are opposite. So if I want to get rid of y, and I have a 2y and a 3y, I need to make those have the same number. So I would make them be 6 and negative 6 so that they cancel out. So if I have an equation with 2y, I'd multiply it by 3. And then my equation with 3y, I'd multiply by negative 2. So that way they have the same number, but they're opposite in sign. And then that way when you add them, they cancel out. And we're allowed to do this because we are allowed to multiply equations by the same thing on both sides. Once you do that, then you add your equations together, which we're allowed to do because we're basically adding the same thing on both sides. They are equal. And so you add them together, and that gives you a new equation with only one variable. And so that's your elimination step. And then you solve that equation. Once you get that answer, then you plug it into one of the original equations to get the second answer. It seems complicated. It's really not so bad once you start practicing with it. There are situations where this method makes more sense to use than the substitution method. So I actually use both methods depending on what form the equations are given to me. So here's an example, and I would use elimination here because my x and y are on the same side. So if they're on the same side, it's pretty easy to use elimination because you don't have to move things around. And in this case, it's pretty simple to make a variable disappear because I only really need to multiply one of the equations. So I could either eliminate y by making it a positive y and a negative y, or I can eliminate x by I have a -2 and a +2. I'm going to choose to eliminate x. So since one of my x's is -2, I need the other x to be a +2 so that when I add them, they add to 0. So we multiply both sides of the equation by 2. And so I indicate that. And so that gives me 2y plus 2x equals 4. Now my other equation is still y minus 2x equals 5. So I've basically multiplied so that I have coefficients that are the same that are opposite, and we add the equations together. And we're adding them vertically. So y plus 2y is 3y. -2 plus 2 is 0, so that x is eliminated. 5 plus 4 is 9. So now I have 3y equals 9, and I'm just solving for y. So I divide both sides by 3, and this gives me y is equal to 3. Now that I know that y is equal to 3, I want to plug y back into one of the other equations to solve for x. So you pick which one is easier to plug it in. So I would put it in the second equation because then I don't have to divide by anything to find x. So we have y plus x equals 2, so 3 plus x equals 2. I subtract 3 from both sides, and I get x is equal to -1. So now my ordered pair is x comma y, so it's -1 comma 3. So that's my solution. So that's using elimination or addition. I multiplied one of the equations by a number, so that way I had coefficients that were the same but opposite in sign. Add, solve, and then plug that in to get your other answer. Here we have 5x minus 8y equals -31. And 2x minus 5y equals 6. So we'd want to solve this by elimination or addition. And the reason why I would use that here versus substitution is because if I tried to solve one of these equations for either x or y, I will get fractions. Because I will have to divide by 5 or divide by 8 in the first equation. And -31 doesn't divide by those. Or in the second equation, if I maybe solve for y, I'd have to divide by 5. 6 divided by 5 gets me a fraction. Or say if I was solving for x divided by 2, 5 divided by 2 is also a fraction. So if I look at these and I say, okay, I'm going to get fractions, I don't want to use substitution because it's just harder to work with fractions. So elimination is preferred. Now here, I want to get numbers of opposite signs that are identical in front of either x or y. So for x, I have 5 and 2. So I'd be looking for what is the least common multiple. So I'd want to get those to be both 10. Or if I wanted to get rid of y, I have 8 and 5. So the least common multiple would be, no, not 20. I think it's literally 40. prefer now, if I have a choice between getting 10 and 40, I'm going to choose 10 because it's a smaller number. So I'm going to choose to eliminate x by getting my x's to have coefficients of 10, and I want to have opposite signs. So right now they're both positive, so I have to multiply one of them by negative to get a negative. So let's say I multiply the first equation by a -2 so that I can get a -10 there on the x. And then the second one, I'd want to multiply by 5 so I can get a +10. And I always make sure to write those in. So my two equations, and I always go sideways so I can continue lining them up. So that gives me -10x plus 16y. So you don't want to forget that you have to distribute, so everything has to get multiplied. And on the right, -31 times -2 is 62. And then the second equation, I get 10x minus 25y equals 30. So I'm going to add my two equations together vertically. So -10x plus 10x is 0. Then I have 16 minus 25, so that gives me -9y. And then 62 plus 30 gives me 92. So I eliminated x. I need to divide by -9 to solve for y. And I'm going to get a fraction here. Y equals, I'm pretty sure that 92 over 9 has nothing in common. That, yeah, has nothing in common. So we get a -92 over 9. I probably should have made it like -30 instead of -31. And then that would have been 90, and we could get a whole number here. Actually, let me do that. I can do that. So let's just say this was 30, so that we don't have to deal with this nasty fractions here. So that would give me 60. That would give me 90, and then this gives me -10. Much easier to work with. So we solved, we got y equals -10. And so now we want to plug that into one of the equations to find x. So we want to plug it either the first or the second equation. And it doesn't really matter. I'm going to choose the second equation just because there are smaller numbers in it. So we have 2x minus 5y, and y we solved as -10, and then equals 6. So 2x plus 50 equals 6. So now I need to solve this equation for x. So I'm going to start by subtracting 50 from both sides. We get 2x equals -44. And then divide both sides by 2. And I get x is equal to -21. So my ordered pair is -21, -10. Now we can double check our answer by plugging y equal to, or y into the first equation. Or what I could do is plug both x and y into the first equation. I don't want to do the second equation because I already used the second equation to find x. So let's say we want to check. So I'd be plugging these into the first equation. So that's 5 times -21, because we found x to be nope, not 21, 22. 44 divided by 2 is 22. So good thing that I'm double checking here. Then we have -8 times y, which is -10. And then we want to see, does this give us -30? So pulling out my calculator, 5 times -22 is -110. -8 times -10 is +80. And that gives us negative 30. So then negative 110 plus 80 does give us negative 30. And so that double checks. And so that answer works in the first equation as well as the second equation. And so we've just double checked that our answer is correct. So that is solving systems of equations in a nutshell, basically solving using substitution and elimination. You can choose whichever method you prefer. They both will get you the same answer. It's just a matter of what makes sense for you. The more you practice, the more likely you'll find that you might choose one or the other depending on what the equations look like based off of, which is easiest to use. And when you go on to pre-calc, if you have to take pre-calculus, you'll learn a third method, which is using matrices to solve.